Welcome to homework.
Okay, what is the optical rotation of a sample of positive 2 bromobutane if it is 75% optically pure? And we also need to know what percentages of positive and negative enantiomers are present in the sample. Okay, and then we're going to repeat that process for 50% and 25%. So to determine the specific rotation of our 75% optically pure sample, we need to know what the specific rotation of positive 2-bromobutane is, and this is typically found in a table in your textbook or sometimes given in the problem statement, although it is not here, so we'll rely on outside sources. The specific rotation of positive 2-bromobutane is 23.1 degrees. Likewise, the negative would be negative 23.1 degrees. So if we have 75% optically pure sample, we simply take the specific rotation of positive 2-bromobutane and calculate what 75% of that would be, or multiply it by 0.75. That is 23.1 degrees times 0.75 equals, put this into our calculator, 23.1 times 0.75, and we get 17.325 degrees. With the correct number of sig figs, this becomes 17.3 degrees. Okay, next we need to determine what percentage of the positive and negative enantiomers are present in this sample. Well, 75% optical purity tells us that 75% of the sample can be comprised entirely of the positive enantiomer, and that the remaining 25%, or we'll do 100 minus 75%, is an equal mixture of positive and negative. So then to determine the total percent of positive and negative enantiomers, we simply need to know that the positive will be the 75% that we know was optically pure, plus 1/2 of our 100 minus 75, or 12.5%, for a total then of 87.5% positive. And for the negative, it is simply the 1/2 of our 100 minus 75, or 12.5%. And you'll notice that these sum to 100. Okay, so there we go. That is the process for the 75% optically pure plus 2 bromobutane, plus rotation bromobutane. So let's repeat the process for 50% and 25% pure. So for 50% optically pure, we know that the optical rotation will be 50% now instead of 75% of our 23.1 degrees. That is 23.1 degrees times 0.5, which we can put into our calculator. 23.1 times 0.5 to get 11.55 degrees, or with the correct number of sig figs, 11.6 degrees. As for the total percentages of positive and negative enantiomers, we follow the same process. We know that for the positive, that we will have our 50% that we know was optically pure, plus 1/2 of the remaining percentage, that is 100 minus 50%, which in this case is easily calculatable as 50 plus 25 equals 75%. And we then know that the remaining percentage, that is the negative, is going to have to be 25%, right? And we can calculate that either as 100 minus the 75% we know is positive, or via 1/2 times the quantity 100 minus 50%, the amount that is matched with its positive counterpart. Okay, finally, we have 25% optically pure, right? So our positive comprises 25% optical purity, which means that our specific rotation, our optical rotation will be, once again, the specific rotation, 23.1 degrees, times 0.25. 23.1 times 0.25 gives us 5.775 degrees, or rounded to the proper number of sig figs, 5.8 degrees. As for the total quantities, once again, we know that the positive portion will be the 25% we get from the optical purity, plus 100 minus 25, all divided by 2%, to account for the portion that is matched with an equal amount of negative rotation. And so in the end, we will get 25 plus, and I'll do this in my calculator, 100 minus 25 quantity divided by 2, 37.5, giving us a grand total of 62.5, meaning that the remaining percentages must be due to the negative rotation, which would be then 37.5%. And I forgot percent in this answer.